Good day everyone, this is Marvi Nacur, and today I'll be discussing our observation on the game Tower of Hanoi. For our first observation, we have here, if the number of this is even, then the smallest disk will always go through the middle peg. For us to better understand, here are the illustration of the even number of disks. We have here 4, 6, and 8 disks, which is of course even number. So let us carefully observe the behavior of the smallest disk. For this 4, it went through the middle peg. For this 6, also, it went through the middle peg. And for 8 disks, it also went through the middle peg. And of course, it will always be true for any given even number of disk. For observation number 2, if the number of disks is odd, then the smallest disk will always go through the rightmost peg. Again, let us observe the pattern. We have this number 3, 5, and 7. And carefully observe the behavior of the smallest disk. The smallest disk went through the rightmost peg. This will always be true for every odd number. And for our observation number 3, the total number of moves needed to transfer the tower is actually 2 times the number of the moves needed from the previous number of disks plus 1. And here is the computation of the minimum required number of moves to transfer the Tower of Hanoi from point A to point C. So of course, one disk require 1 move. 2, however, using our observation, it is said that it is 2 times the number of the previous required of move of the previous number of disks added 1. So here, for 2, we have 2 multiplied by 1 plus 1 is equal to 3 moves. So therefore, 2 disks requires 3 moves. And for this 3 or 3 disks, we have 2 multiplied by 3 plus 1 is equal to 7 moves. And 4 requires 2 multiplied by 7 plus 1 is equal to 15 moves. And 5 requires 2 multiplied by 15 plus 1 is equal to 31 moves. And following the said observation, we can get 6 requires 63 moves, 7 will have to take 127 moves, and 8 needs to take 255 moves to be solved. And you are wondering where did the plus 1 came from? Yung plus 1 na po ito is that this is the single move in which the largest disk moves from point A to point C. Meaning po, yung pinakamalaking disk ay isang beses lang po gumalaw, and then the rest will always be the same moves po kasi we are following recursion or recursive formula. The plus 1 is actually the single move of the largest disk, which is the move from point A to point C. But now, we will encounter a big problem. Kasi pag tinanong tayo ng teacher to get yung least possible number of moves nang nire-require ng 100, hindi natin siya kayang mahanap unless makita pa natin yung 98, 99 bago na tayo makuha natin yung 100. Pero we can put the observation into table and observe if may makikita tayong pattern. And then, eto nga, tinable na natin siya. We have n, which represents the number of disk. Yung moves neto na nakalagay dyan is the least possible of moves na nire-require ng disk. And then, if we will get the difference of the succeeding disk and the previous disk, we can get that 3 minus 1 is equal to 2, 7 minus 3 is equal to 4, 15 minus 7 is equal to 8, 31 minus 15 is equal to 16. Now, may nakita tayong pattern dito. 2, 4, 8, 6 can be represented using 2 raised to n. In addition, we can also observe that there is a difference of 1 between the required number of moves and the difference produced by subtracting the previous number of moves. Look at this pattern. 2 minus 1 is equal to 1. 4 minus 3 is equal to 1. 8 minus 7 is equal to 1. 16 minus 5, 15 is equal to 1, etc., etc. Now, we can assume that 2 raised to n minus 1 is the formula for us to solve any given number of n or this. We can verify the formula using this. If we have 5 this, then we must arrive with 31 moves. Previously, may idea na tayo if ilan yung possible number of moves ni 5 or yung least possible number of moves niya. Using the formula that we assume, 2n minus 1, which n represents nga the number of disc, we can substitute n is equal to 5. That's 2 raised to 5 minus 1. So here, we must get 31 moves. And 2 raised to 5 is equal to 32, minus 1 is equal to 31 moves. Therefore, we can use the said formula to get the n number of moves. We can also verify this using another example. So if we have 4 discs, then we must arrive with 15 moves. So 2 raised to 4 minus 1. So 2 raised to 4 is equal to 16 minus 1 is equal to 15, which is the same with our previous observation. So for our observation number 4, we have here the smallest disc will move every other turn, the smaller every 4th turn, and the medium every 8th turn, and so on. So in order for us to verify this observation, we must list down the solution of any given number of discs. In this situation, we have here the solution of 3 discs. So if we have 3 discs, we can name it small, medium, and large discs. Let us carefully observe the pattern created by the small disc. It is said that the small disc will occur every other turn. So let's see. We have here the small disc, the medium disc, again the small disc, the large disc, again the small disc, medium, again the small disc. So this is true that every other turn, the small disc will reoccur. How about every 4th turn? We have here the medium disc. Let us count. Medium, small, large, and small. That's 1, 2, 3, and the 4th turn is the medium disc. And again, kanina diniscuss natin that the plus 1 move will always have to be the one single move that the largest disc will move from point A to point C. And here we can see that the large disc will only have to move one time compared to the other disc. So now we can also approve that the large disc will always have to move one move from point A to point C. So another example, now this is the solution of 4 discs. So we can assume that the smallest disc can be represented as 1, the small disc as 2, the medium as 3, and the large as 4. So let us see the pattern created by the smallest disc. Again, it reoccurs every other turn. So let's see, 1, 2, and 1 again, 3, and 1 again, 2, 1 again, 4, 1 again, 2, 1 again, 3, 1 again, 2, 1 again. Now, that is true that the every other turn, the smallest disc will always have to reoccur every other turn. How about the small, which here is represented by the number 2? Sabi doon, it reoccurs every 4th turn. Now we can count whether it is true or not. So here is 2. Let us count 4 in order for 2 to reappear. That's 2, 1, 3, 2, 1. That's 2 again. And then let's count 4. And then 1, 2, 3, and 4. Again, there is 2. And then 1, 3, 1, 2. And again, there is 2. Therefore, the assumption that the small disc will have to recur every 4th turn is also true. How about the medium turn? It is said to reoccur every 8th turn. We can see that here it is represented by the number 3. So, therefore, dapat makukuha natin pang 8 ulit na lalabas yung number 3. So, magka-count tayo. That's 1, 2, 3, 4, 5, 6, 7, and 8 turn. Now see that every 8th turn, the medium disc will reoccur. So therefore, our observation is true. And now we have the largest disc, which is represented here by the number 4. How many times did the largest disc appear? It only takes one move. Again, I will reiterate the point. Kanina, ay ito yung +1 na sinasabi natin. That the largest disc will only have to move one time from point A to point C. And for our last observation number 5, if the number of discs is odd, then the movement of the smallest disc is from left to right. And then if the number of discs is even, then the movement of the smallest disc is from right to left. Using this diagram, we can see that for every odd number of discs, we can see that the smallest disc always moves from left to right. It follows the pattern 3, 2, and 1. For 3 discs, the very first move was the smallest disc went through the rightmost peg, the second peg, and then the first peg. Same as the 5 disc. The third peg, second peg, and the first peg. Then the 7 disc, the third peg, second peg, and the first peg. As we can see, it indeed follow the left to right pattern or the 3, 2, 1 pattern. For even number of discs, we have to follow right to left pattern. So we have here 4, 6, and 8 discs. It follows the pattern right to left or 2, 3, 1, 2, 3 pattern. So for the fourth disc, we have 2, 3, and 1 pattern. The smallest disc went through the second peg, third peg, and the first peg, and it will return to the second peg, third peg, and the first peg again. So for the 6th disc, again, it went through the second peg, third peg, first peg, second peg, and third peg. 8th disc, it went through the second peg, third peg, first peg, second peg, and third peg, following the pattern right to left. That's all for today. Thank you for listening. This is Marvi Nacur of group number 1, and this is our observation on the game Tower of Hanoi. Thank you guys.